One of the most intriguing stars, I figure, is a star that could be stunning in our sky. Betelgeuse, also known as Bug Squeeze. It's a massive red star, and if it were in the position of our Sun, it would extend out to the orbit of Jupiter. It's huge, highly unstable, and is going to explode. It could be tomorrow, or it could happen during this broadcast. It would shine like a second sun in the sky because it's only 600 light-years away, making it potentially one of the most spectacular galactic events ever. Recently, renowned physicist Brian Cox has given the world something to ponder. According to Brian, one of the brightest stars in the constellation of the night sky, Betelgeuse, the red giant star, is on the verge of a supernova explosion. Data gathered by astronomers also confirms this impending event. Now we wonder, are we going to witness a catastrophic supernova explosion, or is it just speculation? Let's examine the danger surrounding Betelgeuse and consider the warning Brian Cox has about this potential cosmic event. Betelgeuse, the massive red star, earned its name and shines brighter than most of its counterparts. Located in the constellation Orion, specifically at the left shoulder, it has long been notable for its distinctive features. It's difficult to regard the new findings as routine, as they have rekindled interest in this giant celestial body. Typically, a star is classified as a normal supernova if it's more than 8 times the mass of our Sun. However, Betelgeuse defies convention by being over 900 times the size of the Sun, more than anyone could imagine, and over 20 times as massive. Recognition of this giant star dates back to the Greek astronomer Claudius Ptolemy, who noted its cloudy appearance, at a time when star characteristics were limited to color and position. With modern instruments and research, analyzing celestial bodies like Betelgeuse has become more straightforward. The giant red star appears to be aging rapidly, increasing in mass as it continues to exist. The star is about 8 to 8.5 million years old, ancient by cosmic standards but relatively young in human terms. Given its properties, it's safe to say that the enormity of this star, if imagined next to our Sun, would likely displace the first 4 planets, including Earth. How this red giant accumulated its mass fascinates scientists, and only adds to the interest in it. Continued investigation has revealed that its size is not random but part of its overall stellar life cycle. Currently, Betelgeuse is in its sunset phase, marked by expansion, cooling, and the fusion of hydrogen into helium in its core. This stage, called the supergiant phase, is the result of millions of years of evolution, undergoing various cycles and transformations from the hot blue star it once was to the red giant it is now. This change is influenced by nuclear fusion and gravitational forces. The color change of Betelgeuse is due to the cooler temperature of its surface compared to other stars, including our Sun. While the Sun's temperature is around 5,500 K, Betelgeuse's surface temperature is around 3,500 K, allowing the star to emit light at wavelengths that give it a red appearance. This star's color is not only a visual characteristic but also indicates its current condition, including gas exchange and immense size. Ancient records from Chinese and Roman astronomers suggest that around 2,000 years ago, Betelgeuse was predominantly yellow, with the first recorded description of it as red in the 9th century by Arabic scholars, hinting at its evolutionary path. Besides its color, another key feature is its brightness. Betelgeuse is classified as a semi-variable star, meaning the intensity of the light it emits fluctuates over time. The brightness of Betelgeuse typically follows a 400-day cycle, with a longer cycle spanning around 5 years, noted since 1836 by Sir John Herschel and possibly observed earlier by indigenous oral traditions. However, the marvel of Betelgeuse is not solely based on its color or brightness variations, but also on the irregularity of its behavior. Usually, stars follow a predictable pattern, but Betelgeuse's brightness changes, dimming and brightening, reveal more about its composition and cycles. In recent years, this red giant has captivated astronomers and stargazers worldwide with an unexpected transformation in appearance and color. This event, now known as the Great Dimming, occurred in 2019 when Betelgeuse started dimming mysteriously. This drop in brightness was so sudden and intense that it lost its brightness at an average rate of 0.1 magnitude per day, reaching its lowest point in February 2020. Betelgeuse typically dims every few years, and each cycle lasting around 6 years results in dim spots or star spots on its surface. ordinarily visible to the naked eye. Even in light-polluted areas, Betelgeuse appeared noticeably fainter to amateur observers during this period. A star like this is far from ordinary, and although it may appear close to us, we are not seeing it in real time but as it was in the past. Light from Betelgeuse takes about 725 years to reach us, meaning we are always observing its past, which presents challenges in predicting its behavior. During the recent study, a team used the Hubble Space Telescope to analyze Betelgeuse's patterns and properties. This was the initial phase of a 3-year study to observe the changes in Betelgeuse's outer atmosphere. Observations contributed valuable insights into the dynamics of variable stars like this, known to expand and contract as well as increase and decrease in brightness. The Hubble Space Telescope was particularly useful due to its sensitivity to ultraviolet light, which allowed researchers to study the different layers of the star's surface, where heat results from the sun's turbulent convection cells, involving the upward movement of hot gases and the downward flow of cool gases. Besides Hubble, the ALMA Observatory in Chile, equipped with advanced technology, enabled ultra-detailed observations of this remarkable star. High-resolution pictures of the star provide insight into its personal conduct standards and experiences. The revelations made by ALMA innovation have left cosmologists in awe, as they are highly detailed, especially in the region of gas tufts extending from the surface of the star. In February of 2021, the giant star went through a dimming cycle, registering a V-band magnitude of plus 1.64, which, although still bright, was fainter than its usual luminosity. The dim spots, known as star spots or magnetic spots, are parts of the star where the magnetic field is strongest, creating cooler regions compared to the surrounding gas. Essentially, this phenomenon is due to the way the star emits warm gas from its interior to its surface. It's important to note that the magnetic field of Betelgeuse is believed to be several thousand times stronger than the Sun's, trapping gases and forming zones of intense magnetic activity that appear as dark spots. These dark spots on the surface of the giant star are thought to be larger than Earth, covering up to 20% of its surface. The star spots play a significant role in the star's brightness. The more spots present, the dimmer the star appears, as these spots cover areas that would otherwise emit more light. The potential for an imminent explosion is intriguing due to Betelgeuse's proximity to Earth. Recent data has shown that gravitational wave readings, which were below expectations, have caused concern among astronomers. Although data suggests an impending impact, the exact timing remains uncertain. Should this event occur, what might be the future of Betelgeuse? Various theories have emerged to explain the mass and dust ejection. One prominent theory suggests this is a stage right before a supernova explosion, which gained traction due to the belief that Betelgeuse was nearing the end of its life. Further studies by the James Webb Telescope indicate that years ago, Betelgeuse experienced an eruption that resulted in the loss of a significant part of its visible surface. Aside from mass ejection, another event involved the emission of large dust clouds, a rare occurrence. While dimming is typical for dying stars, such events are unique and prompt scientists to investigate further. Unlike our Sun, which undergoes periodic outer atmosphere loss through coronal mass ejections, nothing has come close to the scale of Betelgeuse's recent behavior. Using the James Webb Telescope, scientists are uncovering more about the reasons behind this mass ejection. According to findings, stars lose their mass as nuclear fusion diminishes, and the rate of mass loss will affect the star's fate. Regarding Betelgeuse's mass loss, it could be a prelude to its end. Observations from the Hubble Space Telescope suggest that the star's dimming was caused by the ejection of hot material into space, which then formed a dust cloud, covering part of the star and reducing the amount of light reaching Earth. The dust cloud was formed from extremely hot plasma ejected from a convection cell on the star's surface. As the material cooled, it settled as dust particles, blocking light on the star's surface. Ultraviolet spectroscopic observations from Hubble helped pinpoint the timing of the last dimming event. The ejected mass was measured and found to weigh around 400 billion times the mass usually released in a typical mass ejection, even exceeding the mass of Earth's moon. The giant star moves around 67,000 miles per hour relative to its surrounding interstellar medium, creating a bow shock, a wave formed by its movement. This phenomenon is better observed as the star's outer layers interact with interstellar gases and dust, providing insight into the star's current state and its mass loss process. It has also been observed that since the large mass ejection, Betelgeuse has been in an unstable state. Hydrodynamic simulations suggest a connection between the star's convective activities, mass ejection, and subsequent pulsation mode switching. The pulsation responsible for mass loss is limited due to constant energy distribution through shock heating. Professor Saver Vitali at the Massachusetts Institute of Technology reported that a detected wave from Betelgeuse's direction may not have originated from it. He explained that neutrinos are usually emitted before a supernova explosion, and with this giant star, none were detected. Also, the fact that Betelgeuse is still visible in the night sky, albeit dimmer, makes it an unlikely source for the gravitational waves detected. The detected waves' characteristics are inconsistent with known mergers, ruling out natural disturbances as a cause, leaving the exact nature of the wave uncertain. Gamma rays emitted after a supernova explosion can be much more powerful than solar energy, and if directed toward Earth, could pose a threat to life by damaging DNA. The last recorded supernova visible from the Milky Way occurred in the 1600s. Supernovae are of two types, one involving a white dwarf star undergoing a runaway nuclear reaction, and the other, known as a core collapse supernova, resulting from a star collapsing under gravity after depleting its nuclear fuel. The core collapse supernova is fascinating, as it emits light and numerous neutrinos. Neutrino emission may indicate that the explosion could extend over days or months. Astronomers have established an early warning system for supernovae called SNOOS, a network of neutrino detectors across many countries. An imploding star could form black holes, and the sudden halt of neutrino flow could signal such an event. As astronomers search for missing stars, they may find potential black hole regions by observing empty spaces in star catalogs. Massive stars are also included in these observations, as despite their size and prominence, they can still undergo devastating supernova explosions. Concerns persist about their proximity to Earth and the possibility of their explosion. Evidence of a starburst event that affected Earth around 2 million years ago points to the presence of radioactive iron atoms, known as iron-60, which are produced only in supernovae. Is a Betelgeuse explosion inevitable? Would Earth recover from such an event? Leave your thoughts in the comments section. If you enjoyed this video, don't forget to like, share, and subscribe. Also, click on the following video on your screen for more content you'll enjoy.